Hi, so welcome back, and today we're going to discuss on the general theory of Frullani integrals. So it's called the Frullani integrals, and we have all been dreaming and praying for an integral formula that we can use to evaluate definite integrals, so that when you look at an integral, say integral from a to b of f of x dx, it will be some formula, more like when you have a quadratic equation to solve ax squared plus bx plus c, where you are told x is negative b plus or minus square root of b squared minus 4ac over 2a. So here we are praying for a formula that allows us to solve a definite integral just by plugging some of the values. Like here, if you have f of ax minus f of bx, we just plug in logarithm of a over b and take the limit as the f of x goes to infinity, and then also f of 0. So this is what we have been praying and crying for. But then unfortunately there is no such general formula for integrals, but there are specific formula for some special cases. And this why Frullani integral is especially useful is because you are going to encounter them. Like I have solved like 30 up to 50 problems where you don't even think that you are going to even use this formula for the integral, and then next thing it pops up. Like it's so useful because although at first you need to arrange the integral in that form. Now when I say I've solved, it doesn't mean that I've made a video of it yet. I solve, everybody knows I solve math and just take pictures, convert to LaTeX and post on my social media platforms. But now I decided to let me make videos, let me take video making seriously, let me show the world how, I want to show the world the beauty of integrals and why integrals are useful and why we should appreciate them. So I'll be making many videos. There's so many videos to make on Frullani integrals, Ramanujan theorem, integration by parts. There are so many beautiful integrals to make, so I'll try my best to making at least a little bit. So but for today now, we're going to enjoy these Frullani integrals, and I'm going to use the double integral method for it. But because you notice that fundamental theorem of calculus says that f of b minus f of a is going to equal the integral from the integral from a to b of f of x dx. Then f of x, where this capital F would be such that f prime of x is going to equal the capital F of x. So that is what the fundamental theorem of calculus tells us. So we're going to use this principle, and we're going to observe here that, in short, f of ax minus f of bx is equals to the integral from ax to bx of what? F prime of t dt. Okay, because the integral of f prime of t is just going to equal f of t, and then here you are going to plug in for ax. You are going to take ax and then bx here. Okay, no, we're going to start with bx yet. So where's the eraser? So we're going to start with bx, and then we'll have bx here. Oh, sorry for that noise. And ax here. So we're going to have bx at the bottom and ax at the top. So that means this is going to equal f of ax minus f of bx. So essentially now you can see that it is possible to represent this as a definite integral itself. So going back to our Frullani integral, the integral from 0 to infinity of f of ax minus f of bx all divided by x dx is going to equal the integral from 0 to infinity 1 over x times what? The integral from bx to ax times what? F prime of t dt, and then you have dx. So you could combine them obviously, but what we want to do here now, we want to swap the region of integration. Instead of doing the t, we want to work out the x. Now if I to do that, what is the range of t? The range of t is that bx is less than or equals to t, which is less than or equals to ax. So that is where t ranges. So basically that means that t is bigger than or equal to bx, or t over b is bigger than or equal to x, which means that x is less than or equals to t divided by b. And also notice that since t is less than or equals to ax, it means that t divided by a is less than or equals to x, or x is bigger than or equals to t over a. So basically you have t over a less than or equals to x less than or equal to t divided by b, which means that this whole integral will then equal the integral from 0 to infinity of 1 over x. Then you will then have the integral of, then instead of bx we'll have t over a, and then instead of ax we'll have a t over b. And what we have done here, we're going to write f prime of t, then you would then have dx and then dt. So we have successfully switched from dt to dx. So we're going to now collect like terms. So this is the integral from 0 to integral of 0 to infinity, and then you would then have we have to bring out f prime of t here. Okay. Yeah. Oops. Where is sorry. Pen is messing up. Okay. Yeah. So you have to now have the integral from t over a to b to t over b of 1 over x dx. Then you have dt. Yeah. So essentially this will give you the integral from 0 to infinity of f prime of t. Then this case you have log x from t over a to t over b, then dt. So that would be the integral from 0 to infinity of f prime of t. Then so you have logarithm of t over b minus logarithm of t over a. So that would be logarithm of a over b, I believe so. So you have dt. Okay. So that would be, we can factor it. I have logarithm of a over b times the integral from 0 to infinity of what? So you have f prime of t dt. Then this would be because it's already f prime of t, this is just basically the logarithm of a over b times what? Times f of t from 0 to infinity. So we are going to have, this is going to equal f of infinity minus f of 0, all in brackets, times the logarithm of a divided by b. So you can see that we have established something here. So we have established the fact that the integral from 0 to infinity of f of ax minus f of bx all divided by x dx is f of infinity minus f of 0 times logarithm of a divided by b. Now what have we gained here? Well, you may be asking me, what are we going to be doing with this formula? Well, from now I will create a playlist for this. So I will title it Frullani integrals. Then we're going to be uploading integrals, whereby to solve them you will need to know that Frullani formula. So that's what we're going to be doing, and hopefully before the year runs out we will have more than 50 to 100 integrals solved, all with Frullani integrals. So this is basically just the theory, just the proof of the formula. So next up we're going to be uploading more videos on this. I also did the same for the Ramanujan master theorem. So I hope you enjoy yourself, and thank you very much for watching, and please do subscribe and like. Thank you.